Hi guys, Paulo Souza here from Holland and welcome to this video tutorial for week 2 assignment, and today we'll be talking about analog to digital conversion. So an analog to digital audio converter converts an incoming electrical pressure sound wave into binary language, the ones and zeros, and in order to the audio signal to be recorded, processed or stored. An analog signal is continuous, usually seen as a waveform, and we vary the amplitude or the frequency to change the shape of that form, where all the digital information is stored as a series of two states called binary. And it's either a positive or a non-positive, 1 or a 0. And each of these digits are called a bit. If you have a string of bits together, it's called a byte, and usually a byte is 8 bits. So from analog to digital conversion we have two key steps. The first step is sampling. That's when the converter takes a snapshot of a wave at a particular frequency, for example at 44.1 kHz. The second step is quantization, assigning a numerical value to the signal level, and which gets coded as binary number, which the computer can read. The precision of this is determined by the bit depth, example 24 bits. So let's take a look on how this works. Here we have a waveform from plucking a string from a guitar, and we will take samples or snapshots at various points along these time intervals, and along these points we will get the value of the waveform, so we get a sample of what is going on each of these points. That is sampling. The next step is quantization, and the first step on that is to figure out what the range of the maximum and the minimum values are for the waveform. Then we will cut that in half, so here above you will have 1, and this below will be 0. So you have above and below two states, and then we will divide each of this into another two, so we have above and below, above and below. So looking at this point right here, we can see that it is on the upper part of the range, so the number will be 1, so here. But then this part here will be 0. And this last one here is below the yellow, so it will be a 0, so 1, 0 and 0. For the first point is below, so it will be 0, but it's above the green line, so here at the bottom part, so it's a 1. Then for this section here will be the below, so it will be 0. So what we have here is voltage as a function of time being changed to binary codes, so the computer can read. So when we take a look here, we can see that the frequency rate is splitting things up in one direction. Well, the bit depth splits the grid up in a different direction, so the higher the frequency, the more samples you get. The more division you will have going this way is the more bit depth you have, and these two things together leads to a true sound reproducing. And the industry standards for this rate are 48 kilohertz for the frequency and 24 bits for the bit depth. So what does this means in terms of recording in the studio? So here we have analog versus digital recording. So an analog signal are continuous noisily and included, and digital can only understand zeros and ones, and comes extra noise is discarded. Linear formats, the analog linear formats require winding and unwinding a tape, and on the digital, random access to any points on the recording. Tapes can be expensive and degradation over time, and the digital does not degrade over time and can be compressed for storage. And the analog can actually have that warmer sound, the more natural sound quality, while the digital will be a bit more crisp and more mechanical sound quality. So I hope you enjoyed this tutorial and enjoy the course.